Imagine launching a satellite into space without a towering rocket or clouds of exhaust. No deafening roar, no massive fuel tanks, just a giant spinning machine hurling payloads into orbit. Sounds like sci-fi, right? Well, welcome to SpinLaunch, a company that's rewriting the rules of space travel. In today's video, I'm diving into how SpinLaunch works, why it's a game changer for cost and fuel savings, its wild structure, the latest test results, and their ambitious plans for a 100-meter machine aiming for speeds up to 11.2 kilometers per second. Buckle up, this is going to be a wild ride. SpinLaunch isn't your typical space company. Founded in 2014 by Jonathan Yaney, they're building a kinetic launch system, a massive centrifuge that spins payloads at insane speeds before flinging them into space. Think of it like a high-tech slingshot, but instead of a pebble, it's launching satellites weighing up to 200 kilograms. Their big idea? Cut out most of the rocket fuel and pricey infrastructure that traditional launches rely on. Instead of burning tons of chemical propellant, SpinLaunch uses electricity, potentially from renewable sources like solar or wind, to power their system. It's bold, it's crazy, and it just might work. So why does this matter? Let's talk advantages. First up, economics. Traditional rocket launches are expensive. SpaceX's Falcon 9 costs around $6,000 per kilogram of payload. SpinLaunch? They're aiming for $1,250 to $2,500 per kilogram, potentially slashing costs by half or more. And their full vision promises launches under $500,000 a pop. How? By ditching most of the fuel. A typical rocket is 85% fuel by mass at liftoff. SpinLaunch claims their system uses 4 times less fuel by spinning payloads to hypersonic speeds, around 7,500 kilometers per hour before release. Then a small rocket booster finishes the job to reach orbit. Less fuel, less cost, and a smaller carbon footprint. It's like trading a gas-guzzling truck for an electric scooter, except this scooter's headed to space. Now let's get to the cool part, the structure. Picture this, a colossal vacuum-sealed chamber like a giant drum with a carbon fiber arm spinning inside. Their current test machine, the suborbital accelerator, stands 33 meters tall, taller than a 10-story building, and it's only a third of the size of their planned orbital system. Inside, a payload is attached to one end of the arm, balanced by a counterweight on the other. The chamber's a vacuum to cut air resistance, and the arm spins up to insane speeds, think thousands of RPMs, before releasing the payload through a tube into the sky. It's got to withstand forces up to 10,000 Gs, that's 10,000 times Earth's gravity. This isn't just engineering, it's a physics-defying marvel. But does it actually work? Let's look at the latest tests. Back in September 2022, SpinLaunch ran their 10th suborbital test at Spaceport America in New Mexico. They launched a 3-meter-long test vehicle carrying payloads from NASA, Airbus, and Cornell University. It hit speeds over 1,600 kilometers per hour and reached 7,620 meters, about 25,000 feet. That's not orbit yet, but it's a huge step. The payload survived 10,000 Gs and worked perfectly afterward. Since then, they've been quiet about exact updates, but by March 2025, they've likely refined the system further. Each test proves their tech can handle the brutal forces and still deliver. They're not just spinning for fun, they're building confidence for the big leagues. So what's next? SpinLaunch is scaling up to their orbital accelerator, a beastly 100-meter diameter machine, 3 times bigger than the current one. Their current goal? Reach 8,000 kilometers per hour, that's 2.2 kilometers per second. To hit that, they're targeting around 450 revolutions per minute, though exact numbers depend on the arm length and final design. At that speed, a payload could climb to 60 kilometers, near the edge of space, where a small rocket kicks in to reach orbit at 27,600 kilometers per hour. They've already got 2 machines built, a 12-meter prototype and the 33-meter test rig. The 100-meter version is their ticket to launching 200-kilogram satellites by 2026. It's ambitious, but they're on track. But SpinLaunch isn't stopping there. Their ultimate dream is to hit 11.2 kilometers per second, 40,320 kilometers per hour, right from the ground. That's fast enough to escape Earth's gravity entirely, no booster needed. To get there, they'll need a bigger, stronger machine, way beyond 100 meters. Why? Physics. The faster you spin, the more stress on the arm and payload. At 11.2 kilometers per s, you're pushing materials to their absolute limits. Carbon fiber, steel, whatever they use has to be next-level tough. Plus, air resistance at those speeds is a killer, so they might need coastal sites for thinner atmosphere launches. It's a moonshot goal, but if they pull it off, it's goodbye rockets, hello slingshot supremacy. SpinLaunch is wild, right? It's cheaper, greener, and could launch 5 times a day, way more than any rocket. Sure, there are hurdles, G-forces, air drag, and scaling up, but they've already shown it's not just a pipe dream. By 2026, we might see their 100-meter machine slinging satellites into orbit at 2.2 kilometers per second, with 11.2 kilometers per s on the horizon. What do you think? Will SpinLaunch revolutionize space travel, or is it too crazy to succeed? Drop your thoughts in the comments, hit that like button if you're hyped, and subscribe for more wild tech stories. Until next time, keep looking up, space just got a lot closer.